Hi dear students, let's see this question that came in JEE Advanced from the topic of balanced Wheatstone bridge. Basically here the question is very simple, it's just a calculative based question. So you can see a balanced Wheatstone bridge over here. Those students who are finding slight amount of difficulty, so I can draw this Wheatstone bridge in the more familiar shape, so you will be able to figure it out. So let me do that. So what I'm going to do, I'm going to rotate this by 90 degrees. So T point will come like over here. Okay. So if you see P will come somewhere over here. So this will be resistor 100. Okay. Then S will come over here. This will be 60 ohms. This is point S, and Q and T 300 and 500. So this is Q, this is 300 and 500, right? Now what I'm going to do, I'm going to make this PQ, attach this 50 volts between P and Q. So if you see, this is 50 volts, and between T and S there is a voltmeter which we assume to be ideal. Okay. So in the question, it has been asked that the temperature coefficient of the resistance R3, which is this resistance 300 ohms, is 0.0004. So the temperature is increased by 100 degrees Celsius. So the potential difference between S and T. So basically, we have to find the reading of the voltmeter, and it's an ideal voltmeter, right? So right now, the potential difference between T and S, of course, will be zero because it is in balanced condition. But if you find the new value of this 300, so this will be initial value into 1 plus alpha, which is 0.0004. Let me see how many three zeros were there. So 4 into delta t. Delta t is 100. Okay. So this becomes 300 into this becomes 0.04. So this is 1.04, which will become 312, right? So this resistance becomes 312. Now we have to find the potential difference developed between P and Q. Okay, so one very easy way I can tell you, if we assume potential 0 here, so the potential here, see, whatever current will go in this branch PTQ, so the potential difference developed across this 100 will be in the ratio of the resistance, because this 100 and 500 will be in series. So if you say potential is 0 here, here potential is 50. So the total potential difference across P and Q is 50 volts. So we can say across P and T, the drop of 50 by 6. How did I say 50 by 6? Because total, across 600 ohms, 50 drop has to happen. So across 100 ohms, 50 by 6, correct? 100 upon 600. So I am hoping you understand this, that it will be 50 upon 6, right? This potential will be over here, right? Similarly, the potential at this junction, let me write this BT. BT is simply 50 into 100 upon 600. So this becomes 50 by 6, right? 100 upon 600. Similarly, if you write the potential here, so Vs 50 का drop इस पूरे के क्रॉस होना है, so 60 के क्रॉस कितना होगा, 60 upon this, remember this has become 312, ये 312 हो चुका है, तो 60 upon 60 plus 312, that means 372. Yeah. Now we have to find Vt minus Vs, or basically the potential difference between these two, whatever value will be larger. So 12 से cancel हो रहा है, 12 5 जा 60, 12 3 जा 36, and 1 2 is 1. So this becomes 250 by 31, right? So effectively we have to find Vt minus Vs की magnitude. So if you solve this, you are going to get 25 by 3 minus 250 by 31. When you solve this, you're going to get approximately 0.268, which IT had given the answer range between 0.26 say 0.28. तो इसके बीच में जिसका भी आंसर आएगा, so 0.268 is the answer, and hence this is the correct. So this was merely based on a slight amount of calculation. That's it. Nothing difficult about that. I hope you would have understood, and nothing big about it. Thank you.